Okay, team, what is up? This is going to be the final video for this unit. I'm going to call it Unit 1, Pennant Fever. And I just want to quickly review what it was that we discussed this semester and kind of like where I'm going to be looking for you to demonstrate your understanding. Some of you are just kind of like me and you're like, hey, listen, Hernandez, can I just get one video and just tell me everything? So this will kind of be that video. I don't want to make it too long, so it'll be broken up kind of just into an overall flow chart, you could say, of what we've done this year. So this unit was all about two different concepts. The first one is looking at the probability. And then the other kind of piece to this was combinatorics. And I kind of want to talk a little bit about where these two things come up and then what does it look like to actually put them together. So when we speak about combinatorics, what we essentially have done this year is looking for the number of ways or groupings that events can happen. So here we're looking at like the number of ways or groupings that events can happen. So this is broken up into two different concepts known as combinations or permutations. And combinations are a certain type of grouping, and permutations are a certain type of grouping. To start with permutations, this is where order matters. And one of the questions that you can ask is, do my events, or I'm going to say the word selections, depending on what we're looking at, need to be in order? Right? Do they need to be first, second, or third? Do they need to be in a certain way? Do they need to matter? Right? Um, if you answer yes to this, it's a permutation. If you answer no or even maybe, then it's probably a combination. So you can default to combination. With a combination, order doesn't matter. Similarly, with a combination, we want to look specifically at different ways that things can be together. Okay, it's the total number of ways that things can be together. What that essentially looks like for us is if we have three events, event A, event B, and event C, then that is the same as having BAC or CBA or CAB or ACB, or if we look at this, there's one more, BCA. According to a combination, these would all be the same. Okay, because we don't really care. Order doesn't matter. However, if you looked at all of these, and we have, I'm going to do them again, ABC, ACB, BCA, oops, BAC, CAB, CBA. These are all different. Okay, here we just have the same three letters, you can say, and they're just grouped a little bit differently, but they're all the same thing to us. So this is all one combination. I'm gonna put one combo, and this would be known as like 6 permutations. Okay, this has more order to it because we want things to be in specific order, and these don't. Okay, now this is great and all if you can do this, but where does probability come in? Okay, the probability is the likeliness of an event occurring. Okay. In this specific case, your probability can be a fraction, a decimal, or a percentage. This is how your answer is going to look. Okay. And what I want to do is I actually want to show you really quick how your answer will look in terms of a fraction. And now fractions, I'm going to just say the word is easier to create with probability because it's the number of things we want okay, or the events needed. How many events do we need divided by the total number of events? Or you could just say total events, depending on what you're talking about. This fraction here, this is a probability. So this is how your answer would look. It'd be a fraction. Okay, now you put numbers in there to make sure that it's a fraction, but you can do that. Okay, and then once you divide the fraction, you get a decimal. And then technically speaking, you'd multiply the decimal by 10. I'm sorry, by 100. Multiply whatever decimal you have by 100 to get the percentage. That's the same thing as just moving the decimal place over 2 times, but really what you're doing is you're multiplying it by 100 to get the percentage. So you can do this to get something called the probability. Now, when we're looking at probability, there's a couple things that we need to know in order to help us to make more sense of this. Okay, so probability is broken down. Probability of an event. The opposite of that actually comes into place when we look at some rules. So when we have the probability of something, we have 3 different rules: the complement rule, we have the product rule. Actually, you know what, let's break this down a little bit differently, okay? We have rules, and we talked about the rules, okay? But the rules are essentially broken down into 2 different categories. So the first one is actually just the complement rule, which is the remaining likeliness or the remaining probability. In other words, it is the probability of not the event. Okay, so we have whatever event is, it's the probability of not the event. So let's say we want to find the probability of the complement, this is the notation, the complement of event A. We do 1 minus the probability of event A. Okay, so it's the remaining likeliness for the event to happen. Okay, I put it separately because it's a rule, but it doesn't really help you calculate. And these are actually, there's 2 other rules: product rule and the additive rule. And these 2 actually help you calculate probability, which is why I put them separate. Because product rule, if we have independent events, and if you check out the other video, I'll define independent events. Independent events, you can multiply them. So we get the probability of 2 events, A and B, and we just multiply those 2 events together. Okay. The additive rule is used for exclusive event. And here it's the probability, it's the opposite way of A or B. So we get the probability of A, and then we can add that actual probability in there, and we can calculate a certain probability of 2 exclusive events. Okay. Now, you can go check out the other videos to kind of see just the difference between these 2, but what ends up happening is we need to do something specific. So all of this, if you remember from I just kind of zoomed out a little bit, all of this is part of probability. And all of this is part of combinatorics. Well, we need to put them together. So what does that actually look like for us? Well, when we have probability, let's just say hypothetically we have just some event. I'm just going to call it an event. Okay. We can find the probability of the event actually happening. Now, combinatorics comes in because we can find the number of ways the event, whatever it is, put it like this, number of ways that the event can occur. Okay, so this is where probability and combinatorics comes in, because this is the likeliness of the event happening essentially just by itself. So this is the probability of a single event. Okay, and then we look at the number of ways that the event can occur. So eventually we need to put these two things together. So what we need to do is we need to take the probability of whatever that event is, and then we need to multiply it by whatever the number of ways the event can happen. So eventually we take all of this stuff and we end up determining, hey, wow, we actually have something going on, right? But we're not looking for the probability of it happening only once. We want to see what's the probability of all the different times that it can happen, whatever we're talking about. Okay. So in this case, what essentially can happen is you can develop a probability. Let's say we have the probability of some event. You can use any of the rules or whatever to calculate the probability. And we're looking at the ways that it can happen. So this is actually the combinatorics piece of it. Probability and combinatorics piece. And most of the time, you would actually do the combinatorics first, which is why I talked about it first, to then find some sort of probability, and then use combinatorics again to try and figure out how many times can that thing actually happen. Okay, so a good example of how all of this comes together is the practice problem. And the practice problem that I'm looking at is actually the practice problem called Stop, Don't Walk. So check out the other video on Stop, Don't Walk, and then you'll get a kind of a feel for this. But if you're up here and you're saying to yourself, okay, I know a little bit of each of these Hernandez, then if you can do all of this stuff in probability, then you'll get a 2 and pass. If you can do all of this stuff in combinatorics, you'll get a 2 and pass. If you can do both of them, you'll get a 2 and pass. The moment you're able to start thinking about them together is when you'll reach the level 3 and 4 stages of probability and statistics. Okay. So if you need any help, send me an email, send me a remind message, and I can help you out. But hopefully this helps you look at what you need to review to kind of figure it out. And really, it comes down to the following topics, and you can put it on your cheat sheet if you like. The complement rule, the product rule, the additive rule, combinations, permutations, when to use them, and then something I forgot to put here is actually the formulas for them. So NCR, n factorial, r factorial, n minus r factorial, and then permutations NPR, n factorial over n minus r factorial. Okay. You'll see all of this found onto our practice problem exercises or our study exercises for this week, and that hopefully they should have helped you out. If you have any more questions or comments, let me know, and I'll see you in the next one.